Good morning. Um, Hope everybody can hear me. This is IE 3340 Operation Research for Industrial Engineering. And welcome to this semester. We are going to be working on this material for Operation Research for this semester. This is a very interesting class. This is one of the courses that I really enjoy teaching. It's one of those courses that you will use in practice a lot. It has a lot of applications, and typically, I've been teaching this class for about 6 years now, and students have a good appreciation about the topics, and especially those who are working already or in the industry right now, they can see the value of the concepts that are discussed and taught in this class. So for today, what I'm going to do is to go over the course overview in this lecture. The lecture is being recorded for those students who might not be able to connect. I'm gonna talk also about the way we are gonna manage the class this semester with the limitations of the online environment. And also I'm gonna go over the syllabus, which is already posted on Canvas. So if you haven't accessed Canvas, yes, you can just go there, and on the syllabus page you will have general information about the class, and also you can download the syllabus from that page. The course is going to be managed using Canvas. So let's get started. If you have questions as we move forward with this presentation, I will encourage you to send me a message via chat. If I'm not able to answer that question right away, I will answer it at some point. So let me see. I think, I can go and do the full screen, but I think I'm gonna leave it like this for now, because if I go full screen, then I'm not gonna be able to see if you send me a question via the chat. So let's see if we can move forward this way. So general information about this class. This is IE 3340. This section is 001. This is the only section for this semester. So if you're registered for Operation Research, then you are in the right place. The title of the course is Operation Research. I'm going to be your instructor, Eduardo Perez. I'm an associate professor in the Ingram School of Engineering in the Industrial Engineering program. Been working here for 7 years. And I have offered this class 6 times already. So it's a course and material that I'm very familiar with. So hopefully I can be a good resource for you during this semester. The room this semester this is a online course. So everything is gonna be managed online. And meeting times or the scheduled times for this class are Mondays, Wednesdays from 9:30 to 10:50 a.m. Later in this presentation, we're going to discuss the way the course is going to be managed. But the meeting times are important. Just for now, the exams are going to be managed online, and those are going to be administered during the scheduled time for the class. Okay, so even though we are not going to be meeting live every Monday and Wednesday, the class and the lectures are going to be recorded. But for the exams, those are going to be live, and those are going to, we don't need to do a video conference for the exam, but those exams are going to be available during the scheduled time for the class. So that's something that you need to keep in mind. and we will talk about that later. So this is the agenda for today. The course introduction and motivation, that's the first thing we're gonna do, and then we're gonna go over the syllabus, and I'm also giving you an introduction about myself, so what I do in addition to teaching, and also finally we're gonna talk about email, the instructions on how to send emails to the instructor, and when is better for us to have like a virtual meeting to discuss instead of an email. So there are certain cases in which I'll prefer you to email me, and there are certain cases in which I'll prefer just to have an online meeting with you to discuss specifics. So let's talk about that as well. So course introduction, the idea with this part of the lecture is to get you motivated for the class, about the things that you are going to be learning and how are we going to proceed with that material. So I always start with this question: what do engineers do? So if you don't have an answer for that question, then I'm going to be presenting one for you this morning. An engineer is someone who solves problems of interest to society with the efficient application of scientific principles, by either refining existing products or designing new products or processes. So what we do as engineers, it doesn't matter what type of engineering or what discipline, we as engineers, we are trying to solve problems. So that's what we do. And we can do that in two ways. One way is, well, there's an existing solution, so we can try to refine that solution or make it better. Or maybe there's no solution for such a problem or the problem that we are trying to address. So we want to design new solutions or new products or processes that can be helpful to solving such problems. And this picture showing a drone. So this, 10 years ago, maybe this was technology that was not existing, and now you can see how they're used mostly for picture taking and for getting access to areas that were more difficult a few years ago. So it's technology, is new technology, and we are developing new uses and how this technology can be used to solve other problems. There are companies such as Amazon that are thinking about maybe using them to delivering products, and so on. So that's the idea. We have problems, we have existing problems that we have existing solutions for them, but maybe we can refine, we can get better, more creative, and define new solutions for these problems. So there's what I call the creative process of engineering, and this is, again, typical for all disciplines. So when you're trying to solve a problem, the first thing you do when you follow the engineering method is to get a clear understanding about the problem. So develop a clear description of the problem, which is the first step. And understanding the problem, having a good idea and a good understanding about the problem is very important. Like if you don't have a clear, well-defined problem, then most likely you will end up providing a solution that is not going to fix the problem. So you have to have a very good understanding of the problem to start with. Things like, okay, so who are the key players? So these are the people that you want to interview, or you want to make sure that you take into account all the feedback when you are defining the problem. What are the performance measures? What are the things that you want to improve? Are you trying to improve the throughput? Are you trying to improve the cycle time? Are you trying to increase the utilization of your resources? Are you trying to reduce the cost? Are you trying to increase your profit? So those are key things that you have to define from the beginning in order for you to make sure that you can solve or you can provide a solution for a problem. So when we have a clear description, we have a good understanding, now we can move forward in terms of identifying the important factors. So, okay, I know the problem now. What are the constraints? Do we have a limited budget? Do we have a limited staff? Do we have people that are not trained? Do we have, I don't know, enough space? So those are the important factors that we have to start defining. And then using that information, we can propose or define a model. In this course in particular, we are going to be defining what we call optimization models. These are math models that are used to define problem constraints. And once you have those constraints, then you can identify a performance measure that you want to improve within the bounds of those constraints. Like, for example, I'm running a production line, and I want to increase the number of units that I'm producing in this production line, but I will have some limitations, like, for example, the schedule for my staff, or I will have limitations in terms of the materials that are available, or I will have limitations in terms of the number of parts that certain machine can produce. So I can define a mathematical equation for each one of those constraints. And then after establishing those constraints, I can define a performance measure, like I want to increase throughput within these constraints, and I can solve that problem. That problem is going to tell me, okay, these are the things, or the solution for that problem is going to tell me, okay, these are the things that you need to do in order to get to that, or to improve that throughput. So models are very important, not only for this class, any class that you take probably within the industrial engineering field, you will see that there's some type of model being developed, computer model, mathematical model, or QA model. So there's always models. These are very important for us because we can provide within the model limitations, they all have limitations. We can conduct experiments that will allow us to make decisions, which is that box that we have at the bottom here, conduct experiments. So we identify the factors, we propose a model, and then we do experimentation. With this experimentation, we'll get some insights. We can manipulate the model in order to see, okay, what if I do this? What if I increase this? What if I change the machine? What if I have more time in terms of my schedules for my staff, and so on. So I can manipulate the model and can create more experiments, develop more experiments, and then using the insight from the experimentation, I can confirm the solution and then provide recommendations to the decision makers. Or if you are the decision maker, then you can make a decision, an informed decision based on the data and also the insights that you get from the model. So this creative process, this engineering method, is not only used for this class, it could be used also within other fields or other disciplines as well. But the description that I'm providing obviously is from the operational research perspective. So what is operational research? So I have three terms here that I want to discuss. So operations are activities carried out in an organization. Research is a process of observation and testing characterized by the scientific method. So the scientific method includes situation, problem statement, model construction, validation, experimentation, and then stating candidate solutions. And a model is an actual representation of reality. Model can be mathematical, physical, narrative, is a set of rules in a computer program as well. So narrative set of rules, so we can develop models from different, using different tools. But the idea is that we are representing reality using some type of abstraction. That's what we do with a model. So if we put together these three definitions, we are going to be studying the operations of an organization or a process using these research techniques and using models. That's what we are going to be doing in operation research. We're going to follow the systems approach, which include broad implications of decisions for the organization at each stage in the analysis. What this means is we are going to be considering the impact of our decisions, not only for, like using the example that I explained a few minutes ago, not only for the production line, but also how those decisions are impacting the company. So if I improve throughput for this production line, how is that also impacting the overall performance of my company, for example? We are going to be using both quantitative and qualitative factors. And then using the model, our target is to define an optimal solution. An optimal solution is a solution to the model that optimizes in terms of maximizing or minimizing some measure of merit. So a performance measure, like I mentioned, cost, cycle time, throughput. So we want to maximize or minimize depending on the performance metric. The solution is going to be maximizing or minimizing one of those performance metrics. We're going to take into account the team, which is a group of individuals bringing various skills and viewpoints to a problem, and operation research techniques. So those are the things that you are going to be learning in this class. How to define these mathematical models, analytical procedures, and algorithms that are going to be used to solve the problems. As professionals, yes, I have one question. Okay, thank you. So operational research professionals aim to provide a rational basis for decision making. So we are seeking to understand and structure complex situations. The models that we can, there are different levels of problems, and also there are different levels of models. So if we are going to be looking at, for example, a scheduling problem for a manufacturing line, that could be a problem that is what I call a regular size problem. But if we are going to be looking at problems such as defining the logistics for Amazon, those problems can be huge. I mean, these million variables, million constraints, and solving those problems will take a day or 2 days in a computer. So there are different sizes, different type of problems, and we can attempt to solve them using, especially those are very complex situations. We need to keep in mind that getting the solution for those might take longer in terms of computer power and solution time. But we use this understanding to predict system behavior and improve the system performance. Much of this work is done using analytical and numerical techniques, such as developing mathematical and computer models, or organizational system composed of people, machines, and procedures. So what is the problem-solving process? This is the overall idea of what we are going to be pursuing this semester. So I'm trying to summarize this with this diagram. So as you can see, there's a lot of pieces, well, about 7 pieces here, 6, 7, including data. And what we're going to try to do now is to connect them. You see the arrows pointing in different directions here. So our goal is to solve a problem. That's what we want to do. So in order for us to solve a problem that is well defined, we have the understanding of the problem. We have a good understanding about the problem. The model must be valid. So the model must be representing the situation in a good way. It must be tractable in the sense that we can see how things are connected. Especially if there's a time period association between decisions. So we want to make sure that we are taking into account that timeline in our decisions. And the solution must be useful in the sense that something that is practical, that's something that we can apply, there's something that we can actually implement in the situation. Okay, so we start with the situation here. may involve current operation or proposed development of due to expected market shifts. So maybe there's something happening, like for instance, coronavirus, so that change the way demand, for example, is affecting many different industries. So that's the situation. There's a current shift in the operation. There's current shift in demand. So how can we improve our operation based on that? Maybe become apparent through consumer complaints or through employee suggestions. So these are things that we can use as in terms of feedback. So can we do better? Let's see what is our suggestions and complaints from employees and also from the users. And maybe a conscious effort to improve efficiency or respond to an unexpected crisis. So I have an example here. I do a lot of research with hospitals, service systems. So I'm presenting an example. This is a scheduling problem for internal nursing staff, which is typical in a hospital facility, that you have a group of nurses and then you have to provide schedules for them on a weekly basis. So in this particular problem, we have the staff that is not happy with their schedules, and hospital are using too many external nurses, that they're bringing people from not their staff, maybe subcontracting or subcontracting some people. So when we talk about the situation, now we get these complaints, right? We get this feedback from the users or from the staff, and when we want to improve that situation, so we want to formulate the problem. So what is the problem? How is this situation? How can we translate this situation or this feedback into a problem statement? So that will be the first step. So we have data. That data is coming from the situation, data in terms of feedback, or data in terms of what we are observing in terms of surveys and so on. So that describes the system, define the boundaries, state the assumptions, select the performance measurements. In the problem statement, using that information, we can define what are the variables. What variables will be those decisions that we have to make. For example, in this problem, so which nurses will be scheduled in the morning, which nurses will be scheduled in the afternoon, which nurses will be scheduled on the weekends. How many weekends do we have to provide off for each nurse, and when are those happening? So those are type of the constraints. How many days in a month we need to schedule for each nurse? How many weekends in a row they have to be free? How many weekends in a row can they work? How many times in a week they're gonna be on shift in terms of being on call? Like they have to present it at night when call. So there's a lot of things. So based on those constraints, then we need to identify the data requirements. So this is the data that's gonna help us state the boundaries for each constraint and also the parameters that are needed for the model. So in this example, for the nurse scheduling, we want to maximize individual nurses' preferences subject to demand requirements, or minimize the nurse dissatisfaction with the schedules. So for example, if we have a lot of people asking for the same day in terms of, let's say we have a long weekend and everybody wants to get, for example, Christmas Day. So we know that we still need to schedule people on Christmas for the hospital. So we want to schedule that in a way that we can minimize the dissatisfaction of the staff. So make sure that we have enough people there, but also making sure that maybe there's people that want to work on that day, because you can offer, I don't know, a better rate or provide overtime pay during that day. So we want to define who is going to be working, or the solution should tell us, okay, these many people are needed. These are the people that are going to be working, by minimizing the dissatisfaction or maximizing the nurse preference for that time period. So personal planning and scheduling. This is an example of how to bound the problem. So we can start from the top, long-term planning, defining who are the full and part-timers who have more experience. Typically, seniority is important. So if you're going to provide some type of preference in your schedule, you go by seniority. So people that have been longer with the hospital usually have some type of preference. Then you have to define the shifts. What are the days off? What are the long weekends, or what are those days that are holidays? And then put that as part of your model, and then define the weekly scheduling. So this goes a level down. So now we start with the long term. Now we go to the weekly scheduling. So vacation leaves, who is in vacation, who's in leave, how many hours can we offer in terms of overtime, who are the part-timers, have experience. Typically they have less experience, so they will not be able to handle all type of problems. So that's something also to take into account. And then we can define task assignments. And then going a level down, we went to long term, like we look at the year, now we look at the week, now we are looking at real time. So this is a daily day operation. So we look at how many emergencies are we expecting? What are the type of adjustments that we need to make? What are the sick leave expectations? So if we are, for example, in flu season, how many people call being sick during the flu season? So we need to take into account that. So maybe we schedule 10, but we know on average 1 or 2 will be calling sick. So we have to take that into account. And then overtime. So how many hours can we offer in terms of overtime? So this, again, is just an example of all the things that you have to consider. And you will think about this problem, you say, oh, this is not that difficult. But if as you start looking at all the details that are involved, you end up looking at, for example, a big model, like 100 constraints, for example. So that's why it's important to get all the information and then start planning, bounding the problem from a macro to a micro perspective. And then once you have all that information, then you can construct a model. The problem must be translated from verbal to qualitative terms to logical quantitative terms. So we go from our discussion to numeric values to a logical expression of the constraints. A logical model is a series of rules, usually embodied in a computer program. So we're going to be using computers to solve these problems. Understand the limitations for a course, be online. So solutions, when we start defining the solutions and how to solve these problems, we're going to be relying on software that is available. So for example, we can solve these problems using Excel, using the solver add-in, and there are also other software packages that can be used that we can download and install for free. So we are going to discuss that. The mathematical model is a collection of functional relationships by which allow actions are determined and evaluated. So those are part of our model. We are going to be defining these mathematical expressions in our model. And for example, define relationship between individual nurse assignments and preference violations. Define the trade-off between the use of internal and external nurses' resources. And then once we get the model, then the next part is to solve the model, find a solution based on the constraints and the performance metric. So many tools are available as discussed in this course. So we're going to look at those. Some might lead to optimal solutions. The reason I'm saying this is that sometimes we get problems that are too big. Like for example, the problem that I mentioned about Amazon, planning the logistics for a month, for example. So those are very big problems, and finding an optimal solution for such problems requires a lot of computer power and a long time period. Like you have to keep the computer running for, let's say, a week, and that might not be feasible if you're trying to make decisions right away. Like if you have to plan the logistics and you have to provide feedback by the next day, you cannot wait a week. So there are algorithms that are defined that can give you a good solution for your problem, not necessarily the best solution, but they're faster in terms of providing the solution. So sometimes, depending on your constraints, depending on the timeline of the decisions, you might need to rely on algorithms that can give you a good enough solution instead of getting the optimal. So those are the practical, when you go to a practical setting, the things that you have to consider. Like if you are just doing this for research, you might need to have time, you might have time to wait. But if you're doing this for the day operations, then you might need to get a solution faster, and you might not be able to get that optimal, but you can define some algorithms that can give you a good solution for right away. There might be a difference between the quality of the solution, but a good enough solution is better than not having a solution at all. So again, that's from a practical perspective. So that's why I make this comment: some lead to optimal solutions. In other, only evaluate candidates, try and error to find the best course of action. So for example, collecting input data, nurse profiles and demand requirements, apply algorithm, and then post-process result to get the monthly schedules. Implementation. So after you get the feedback from the model, the next practical step is to go and implement the solution into the situation, the actual situation. So a solution to a problem usually implies changes for some individuals in the organization. And I will say, based on my experience, getting the implementation is one of the most difficult tasks for an engineer, because you're going to face some resistance from the people, especially those that are been there for a long time. So often there is a resistance to change, making the implementation difficult. So a user-friendly system is needed. Those affected should go through training. Another important thing to consider, and these are the things that you gain with experience, and that if you can identify those people that you know that will be making implementation difficult, like those long timers, those people that are been there for 20, 25 years in the company, and you know that after you come up with a solution, those are going to make your life difficult. You can involve them from the beginning in your planning, in your problem definition, in your what you're trying to do. So by the time that you get into the implementation, they know what you have done, and you know what they will be on board, basically. So those are the type of things that you might want to consider. So implement nurse scheduling system is one unit at a time. So instead of going and try to implement this for the whole hospital, you can start in the ICU, or you can start in the emergency department. Integrate with existing HR system, and provide training sessions during the workday. So if you have a new system, a new scheduling tool, you have to provide a training for the people that are going to be using it. Okay, so that's in terms of, so again, this is the overall picture for what we are trying to be learning in class this semester. We go from definition to building the model, to implement, to solving the model, to getting insight, doing some sensitivity analysis in the model, finding better ways to solve the models using algorithms, and then implementation of such type of feedback from the model. So So that's the idea. That's what we're going to learn in this class. As we move forward, I know that some of you have noticed that we have two courses in operational research as part of the industrial engineering program. So these are the differences between the two courses. We have one that focuses on deterministic models and the other one focuses on stochastic models. So in this class, we're going to be dealing with the deterministic models, linear programming, network optimization, integer programming, nonlinear programming. And then the second part is looking at discrete time market chains, continued time market chains, queuing, and decision analysis. So our course is going to be focusing on this left side. Some of the examples of OR, operational research applications are here. Rescheduling aircraft in response to grounding and delays. So operational research is used a lot in airport planning, airport airplane scheduling, airport planning for passenger input and output. So there's a lot of application when you look at airports. Planning production from printed circuit boards assembly, things like Samsung, companies like Samsung, they use this a lot. Scheduling equipment operators in mail processing and distribution centers. So this is from the government perspective, like post office. Developing routes for propane delivery, adjusting nurse schedules in light of date fluctuations in demand, which is the example that we went through. The steps in an operational research study. This is basically a summary of what we went through with the example. So we start with the problem formulation, we build a model, do some data collection, data analysis. We can code the model in one of these software packages to apply a solution method. And then we do some model verification and validation. If we see that the model is representing the actual situation in a good way, I mean, similar to what you should expect, then we can use the model to do some experimentation and get some insight. If not, then we might need to go and revise the model, do fine tune to the model, and then go back to data collection, data analysis, coding, until we get a good model that we can use to make decisions. What roles do operational research play within a firm? So I think I have given you a good perspective already, but we play a significant role in designing and developing new products, new logistics, new implementing new equipment in terms of scheduling and in terms of optimizing the dimensions of a facility, for example, improving existing systems. So I have an example here. This is the Taycan Turbo. This is an electric car. The new Porsche electric car. So I was reading about all the things that went into developing this car. It's not just the design of the car, but also the infrastructure that goes around it. So if you've been producing gas cars for I don't know how many years, now you have this new technology that is different. Like if you're going to assemble this engine, you cannot use the same equipment and machinery that you've been using for the past, I don't know, 50 years. So there's a lot of decision making that needs to happen in order for you to set up that facility. Like you have to plan for where to put that facility so you're close to the suppliers that you will need. Also, what type of equipment, what type of scheduling you need, how many people do you need, how much it's going to cost you. Is this something that is going to generate some profit? So how can you make this a profitable investment? So a lot of decisions, a lot of data that you can use, and then in order to get to this point of developing this new car. So operation research plays a good, it's a key player. Building these decision-making models are very important for you to make decisions that can help you move forward, or basically can tell you whether or not you should pursue this type of project. Why taking this class? As I mentioned from the beginning, this is something that you'll be using a lot. As we move forward, you've seen this movement of data analysis, data analytics. So decision-making models are becoming very relevant as we continue this data movement. Yes, I have a comment. Can be also be used in writing business plan. Yes, of course. Yes, operation research. I mean, if you are planning on opening or developing a business, again, there's a lot of decisions that you have to make. There's a lot of planning. So operation research models can be useful. I mean, you have all this data, and you want to get a good perspective of any decision that you have to make. Like, for example, how many people you will need to start with the business. So you'll have some data in terms of money, budgets, the things that you have to do. So you want to have, okay, I want to know how many staff members do I need now. As we move forward, let's say in 5 years, how many staff members do we need to target, and in which positions, what type of expertise? So yes, I mean, these type of tools can be applied to any type of problem, and including that. Material, I mean, if you're planning on taking the fundamental engineering exam, this class is covered in the afternoon. So if that's one of the things that you would like to do, then you will keep, I mean, using this class and learning about these concepts can help you getting prepared for that. And I think this is also a prerequisite for the other courses. Okay, so now the second part of this lecture is looking at the syllabus. So one thing, I think this year this is very relevant. I mean, every semester is relevant, but this in particular with this new online environment. So we need to be very clear of what the rules are and how we're gonna communicate and so on. So as I mentioned, this is my name, Eduardo Perez. So I have provided you with some information here in addition to my email. So if you're in LinkedIn, you can find me, you can add me if you want to, or if you're in Twitter, you can also do that. I will not use LinkedIn or Twitter for the course purposes. Like, it's not a way for me to communicate things that you need to do for the class. But I use LinkedIn and Twitter mostly to share opportunities like internships, or since I have people in my network that they usually post those through these social network environments. So if you would like to get information about those, then you can connect with me using those two social networks. But the information for the class itself is going to be provided using Canvas, using email, and using Zoom. I will hold office hours, virtual office hours every Monday and Wednesday from 2 to 3:30. So if you have the password that you used to access the class today, it's the same password that you will use to access the virtual office hours. So I'll be connected during that time. Obviously, this will work as typical office hours that we do face-to-face. So if I have someone already in the office, then you will have to wait until I'm done with that person. So I'll put you in waiting if I'm talking to someone else. If you don't want to wait, then the best thing for you to do is to schedule an appointment. and say, okay, Dr. Perez, I need to talk to you. Can I schedule an appointment with you? And I will tell you my availability, and we can schedule that outside this time. So we can work with that. We're gonna have a teaching assistant for grading the assignments, only the assignments. I haven't had, I don't have the name of the person yet, but it's a master's student. I'm gonna be grading the exams, and yeah, the exams are going to be my responsibility. So these are the teaching assistant responsibilities: grade homework and quizzes. We are not gonna have quizzes this semester. I do that when we are in the classroom, but we're gonna have some labs, meaning that you have to watch the lecture in order to know what the lab is. I'm gonna post that description also in using the modules in Canvas. But typically, there's going to be some lectures in which I'm going to explain a concept, and then I'm going to ask you to solve a problem based on that concept that I discussed in the video lecture. So that's what I call labs. It could be something like I start a problem in the video, and then I don't finish the problem, and I ask you to complete the problem as a lab. So I do the first 2 steps, and I leave step 3 for you to complete. So that's why it's important. Like, you will see the notification that you have a lab, but for you to get the whole picture of what to do in the lab, you're gonna have to watch the video. So homework is gonna be assigned, it's gonna be scheduled. You will see that announcement. Quizzes are not going to be part of this semester, but we're gonna have some labs. Those are also announced. But in order for you to get the clear picture of what to do in the lab, you have to watch the video lecture. Course objectives, it's a lot of information here. You can read through this. So basically, course objectives is what you need to learn, or these are things that you have to master by the end of the semester. So I have a lot of things here. We can go through this quickly. The objective of this course is to give the student experience in modeling, solving, and analyzing problems using linear programming. Emphasis will be stressed on theory applications and computer usage. And by the end of the course, the student should have developed these skills. So ability to identify, formulate, and solve complex engineering problems. Consider real-world problems and determine whether or not linear programming is an appropriate modeling framework. Developing linear programming models that consider the key elements of the real-world problem. Solve the models for the optimal solutions. Interpret the model's results. Recognize, analyze, formulate, and solve industrial engineering problems that can deal with linear programming. And develop an ability to acquire and apply new knowledge as needed, using the appropriate learning techniques. Yeah, so that last objective is very general. That's more connected to an AVIT objective, but you see that you'll be able to do that also at the end of the semester. Okay, so how are we going to pursue these objectives? So today's lecture is live because I wanted to do this because it's the first lecture. However, I know that there's some limitations for students in terms of accessing live lectures, like for example, internet might not be working well every day, or sometimes my internet can fail. So I want to avoid having those type of issues. So I'm going to be recording the lectures, and I'm going to post the lectures on Canvas. Okay, so after today, lectures are going to be recorded. I'm going to make them available before the lecture time, and I'm going to show you the structure of Canvas in a minute. But after today, yes, the lectures are going to be recorded. Typically, what I would do is when we get closer to the first exam, I will schedule a review session that will go live. So it will give you the opportunity for asking questions live. But if you want to talk to me live, then you can use the office hours, or we can schedule an online appointment. But from now on, you'll see that the recorded videos will be available on Canvas, and then I'm going to be using modules in Canvas. So this is the Operation Research Canvas site. So if you go, let me use the student view here. So this is the student view. So you will have, when you log in, you'll have the syllabus. That's the first thing you're gonna see. So here are the instructions that we are discussing, how we're gonna pursue the objectives online teaching plan. We're gonna go through that in a minute. If you want to access the course syllabus, you can click here, and then you will download the syllabus. So here's the information that we are going to discuss now. Then we have the links for the virtual office hours here. Password, again, is the same password that you used to access the lecture today. And then when you go here, this is what you're going to access. Like, you have access to modules, assignments, quizzes. These are for the exams, discussions, grades, and people. So when you go to modules, then week by week, I'm going to be listing the material for the class. So the slides for today are listed here. The first assignment is here. And then discussion, I'm not going to be, discussions are not going to be graded. This is just for give you an outlet to, like, if you have questions or if there's something interesting that I would like to share with you. So I will share that through here. For example, I have a discussion open for the history of Operation Research. So if you would like to go read about it, you can click there, and then you can provide feedback. So the video is going to be also listed here, and I'm going to have a module per week. So as now, you have the information for today's lecture, but by Wednesday, you'll see that lecture 1 will be posted with the slides, the video, and also the assignments, if there's any assignment. So you have access to everything through here. So if you click here, you can download the slides. If you click here, you will go to the assignment. And if you click here, you'll go to the discussion. If we click back to home, we go back to the syllabus. I'm going to be keeping the grades here, and then you have the assignment grades, the weight per group. So we're gonna discuss this in a minute. But this is how we're gonna manage everything from here. So Dr. Perez will use the modules tool within Canvas to upload the lecture videos, list the assignments and due dates, and provide additional instructions per lecture. Lectures will be conducted following the schedule stated on the syllabus. So if you go to the syllabus, at the end of the syllabus, you have the schedule for the lectures, the exams, and everything. Once posted, the video lectures will be available for the students to access them anytime during the semester. Students will be notified when videos are posted using Canvas. Okay, so even though the videos are available there, you can access them at any time, you will have to submit the homework and the assignments on the due dates, by the due date. Okay, so want to make that clear. So assignments and labs will be posted in Canvas using the assignment tool. So you will access those also using the modules. So if there's any assignment, it will be listed here. You see assignment. They are going to be part of the lecture content for that week. Same thing for the for the labs. Students will upload their solution in Canvas using the assignment tool, and feedback and grades will be available in Canvas using the grades tool. Exams. The exams will be posted and available in Canvas following the schedule stated in the syllabus. The preparers will design the exams to limit academic dishonesty. So, for example, there's an option in Canvas that I will be using in this class in which you answer one question and then you move to the next one. And then you are not going to be able to go back to that question. So that's the type of exam that I'm going to be designing. So you will be answering a question and then moving to the next. That's, for me, is a way to limit academic dishonesty, because you have to move on a specific pace in order to complete the exam. So you will have to focus on your own pace in order to make to the end of the exam. So keep that in mind, and we'll go over that when we get closer to the exam. Dr. Perez will use quizzes tools within Canvas to administer the exams. Office hours, the whole office hours schedule in the syllabus. The parents will use Zoom to communicate with the students during the office hours. The parents will be available to the students online during the office hours. Students will be able to join Zoom meeting with the professor without an appointment. Although a password will be required to join the meeting, that the parents will send the password to the student. In terms of the textbook, these are textbook for the class. This is an expensive textbook. I think there's options in which you can rent the book. For those of you who cannot purchase the book, if you have access to the library, there's a copy in the reserve, so you can access the book. But the material that I'm going to be providing, the book is recommended, it's not required. The material that I'm going to be discussing in class should be enough for you to do well in class. And the homework, I'm going to be providing you with the problems. So the problems are going to be stated in the homework. So the book is a good reference material if you want to reinforce what we are discussing in class. And I'm also listing some additional references here that are useful, that are very good. And the course website is going to be Canvas. This is the exam schedule. So the first exam is going to be on Monday, September 28th, during the class period. Okay, so the exam is going to be available during the class period. Saying exam number 2 is scheduled for October 28th, Wednesday, and exam number 3 is scheduled for December the 2nd. There's 3 exams, and I have a final exam that is comprehensive, that includes all the material for the semester, and that's scheduled for December the 5th. However, the final exam is up to the student whether or not they want to take the final. And I'm going to talk about that in a minute. So basically, the idea is that if you do well in exam 1, 2, and 3, and you want to keep your grade up to that point, then you don't have to take the final. But if you feel that the exam can help you improve your grade, then you can take the final, and the percentage or the weight for the other 3 exams will be reduced. The final weight will have a higher weight, and I will talk about that in a minute. Homework and labs. Sorry, I thought I have removed this, but there's no quizzes. Homework will be assigned. Only some of the homework assignments will be collected for grading. I will announce which assignments to be submitted. So those assignments, this again doesn't apply this semester. Sorry, I thought I have removed that. So I will let you know which homework will be assigned, which homework is going to be collected. I think for the typically what I do is I assign a homework and I tell you which problems needs to be submitted. Yes, so I have Jackson.
Yeah, you say in the syllabus that you're going to announce which assignments have to be submitted. Are you going to be announcing it through like a Canvas announcement, like the text messages you've been sending out?
Yeah, so that's what I was gonna say. The assignments, in the assignment, I will let you know whether or not you have to submit. They are gonna be posted, so you're gonna have to read the instructions and say, okay, I have to submit this one. So for example, there's gonna be times in which we have the exam on Wednesday, and then I have homework on assignment that is posted on Monday. So turnaround time for that homework is going to be very limited. So I will let you know, okay, this is the assignment. Most likely what I'm going to do is going to provide you with the solution. So you can try the assignment and then check with the solution whether or not you are doing the problems in the right way. But that particular assignment will not be submitted because I'm going to be giving you the solution from the beginning. So that's what I'm referring to with this instruction here. So you can basically assume that you will have to submit all the assignments unless the assignment is due like very close to the exam. That for those assignments, I will provide you with the solution, and then you will not have to submit that assignment.
I see. Thank you.
Yeah, no problem. So I have a question here. So we are not meeting on Zoom going forward. Yes. So yes, that's correct. So after today, I'm going to be posting the videos, and they are going to be available by the time of the lecture. So for example, on Wednesday at 9:30, you will have a video available for you to access with the homework and with the if there's any lab that you have to complete. But yeah, the lectures are going to be recorded beforehand, and you can access them at your convenience. But remember, there's going to be deadlines for the homework, so you want to access that information on time so you can submit the homework by the deadline. Awesome. So moving forward, so assignments are due at the beginning of the lecture, meaning that if I have a deadline for the assignment, I'm typically give you a week to submit the assignment. So if I for example, today's assignment, that is due by Monday at 9:30 of next week. So I typically give you that time frame, so you can plan ahead. So 9:30 is going to be the cutoff. So if you don't submit by 9:30 of next week, then the assignment is not going to be accepted. So no late work will be accepted. Makeup assignments will not be given. Any student who fails to submit a graded assignment on time will be awarded 0 score unless there exists a legitimate medical emergency reason, and you can provide that documentation to support that. Labs are practice problems assigned during the class period. So as I mentioned, they're going to be announced in the modules, but in order for you to get the whole perspective of what you need to do in the lab, you have to watch the video. So you'll be required to work in small groups and submit your answers before the end of the class period. So when I said by the end of the class period, typically labs are going to be due that day. Like if I lecture today, let's say I have a video lecture posted on Wednesday and I have a lab on Wednesday, then I will give you until the end of the day on Wednesday to submit that solution. The reason I'm doing that is because I want you to keep up with the material. I don't want you to let the videos to accumulate. So if I assign a lab during that lecture time, then you'll be asked to submit that lab by the end of the day. Okay, so end of the class period in this What I mean is the end of the day for the lecture, for that lecture. Okay, so assignments, you'll have a week. For the labs, you have to make sure that you go over the lab material on that day where the lecture is assigned. The course grade is as follows. Grade distribution with the final exam option. So if you want to take the final, homework quizzes are 10%, exam 1 is 22%, exam 2 is 22%, exam 3 is 22%, and the final will be 24%. So this has worked well for students that do well in 2 exams and they don't do well in one of them. So you can take the final and then you can improve your grade. But if you feel that the grade that you have gotten so far is good enough and you don't want to take the final, then the final distribution or the grade distribution without the final is to your right. So homework quizzes will not change, but then I'm gonna give the exam weight, the exact weight, same weight for each one of the exams, 30% for each one of them. Yes. What do you mean by the end of the day for lab submission? 11:59 p.m. of the same day. That's correct. That's correct. So the lab has to be submitted, like the lecture time is 9:30, and then it ends at 11. So you have until 11:59 p.m. to submit that lab solution. That's correct. So basically forcing you to keep up with the lectures and you don't let the videos accumulate. Labs are not going to be assigned every lecture, but there's going to be some lectures in which you have to submit a lab. Grade distributions, no final option. So, I mean, I think this is clear. If you have any question about this, you can raise your hands now. But if you want to take the final, this is to your left. This is the grade distribution. If you don't want to take the final, then you know that the exams will have a higher weight. So if this works for you, at the end you have, for example, an 82, and you know not taking the final will not, I mean, taking the final is not going to help you, so you can keep your 82, which is a B. Or if you have a 90 and then you want to keep your A, then you don't have to take the final. But for example, if you have a 78.5 and you will benefit in those cases, if you have a 78.5, then taking the final might help you go to the 80. So that's the type of leverage that you can use in terms of taking or not taking the final. So the grades, I use the standard curve. So I will not curve. I would not curve without the final. So if you want to, you have to make sure that you follow this. If a test is missed, you must have a written authorized excuse. If possible, please let me know before the test. Otherwise, I must be notified within 2 days of your return to school. I have to. For the lab, how do we work in a group? So there's no group labs. Yeah, obviously because of the limitations of the online environment. So so typically this will happen during the class period, and the small groups will happen within the class. So yes, this is a limitation that we're not going to be able to do the small groups in class, especially since all of us will be working in separate locations. So yeah, I didn't catch that. So in this case, you will have to work individually for the labs. So make sure that if you have to miss an exam, that you talk to me because let's say you're sick. Make sure that you talk to the doctor and you get an excuse, like you can go to the health center in university if you are on campus, or you had to find some type of excuse if you miss the exams for me to work with you and reschedule the exam. Yes, I mean, the labs, if you want to work in groups, if you want to work together in the labs or in the homework, I'm not against that. That's an option. I actually encourage that, but you have to make sure that you submit your own work. That's the only constraint. So if you want to do that, if you want to get together online with some of your classmates and do that, then you can do that. Or if you want to work individually, that's fine too. But yes, I don't have, I'm not against that. Just make sure that you submit your own assignment. That's your own work. Okay. Then any disagreements regarding the grade received or any material must be discussed within 1 week of the return of the graded material. So if I give you feedback about the homework today, then I expect you to get back to me with feedback, like if you have questions or you feel that you were not graded correctly, make sure that you talk to me within a week so we can fix that. The worst thing that can happen is that you keep your same grade. So if you feel like you are not graded fairly, just get back to me and I will look at it, and when we can make any revisions if needed. But that needs to happen within a week. Same thing for the exams. What I'm trying to avoid with this is like we go the whole semester, and then at the end, let's say in December, I'd want to avoid having questions about the same first homework, for example. So let's work on a timely basis. So by the end of the semester, we are in good shape. So yes, I'm sorry. This should be hidden. I mean, since I'm not using the full screen, this slide should not. I mean, this is hidden. I'm sorry. This is not here. I have the per grant, and if you have any of these grants, make sure that you follow this instructions from the university. So I'll leave you to read through this if this is your case. Unofficial withdrawals on financial aid. So again, if you are getting any type of funding for your degree and anything, make sure that you follow these requirements from the university. So make sure that you don't lose your financial aid. You meet these requirements, so you can read this on your own. If that's your case. Academic integrity. So we are going to make sure that we want to maintain this scholastic integrity at the university by refusing to participate in or tolerate dishonesty. So if you have questions about this, you can read the honor code. Plagiarism will not be tolerated and will result in an F in the course. So again, if you're working together in a lab or if you're working together in a homework, make sure that you submit your own work. So you write your own stuff and you submit your own stuff. Academic with disabilities. So if you require any type of special accommodation, make sure that you provide me with the information that is needed, and we can work with you. So just contact me and I'll make my best in accommodating your needs. This is also hidden. Sorry, since I'm using this, I'm not using the full screen or the slideshow. Those slides are not that don't apply to today's are showing up. So so this is the topical online. outline. So here we have the dates and the topics that we are going to be covering per day, per week, and the dates for the exams and so on. So something else that I have provided you with is if you want to look at the textbook, the material is listed here. So which sections and which chapters we are referring to in terms of the topics that we are covering in class. So that can help you tie the book material with the lectures that we are covering. So we are running out of time. I have some slides here discussing email communication. So I just want to make sure that every time you send me an email, I can address that email the best way possible. But I need your help to make that happen. So this semester I'm teaching 2 courses. So first thing I always ask the students is to name the course that you're taking when you send me an email, so I know which class you're referring to. So include your class and what the email is specifically regarding in the subject. So for example, IE 3340, if you have a question about the exam or the homework, something like this will be great. You just state the question and your name and the class. Try to keep the email brief. Response to email within the same time span you will do for a phone call. I think I will not send you an email unless it is important, like an individual email. Typically, the emails that you will get from me are for the class. So those emails are going to be for everybody. If I send you an email to you specifically, it's because it's very important. So I will encourage you to respond that email as fast as possible. But that will not happen unless it is really needed. The emails that you will get are class emails, same information for everybody. But if I send you an email to you independently, then that means that it's something important that needs to be addressed quickly. Use a professional font, not decorative. The reason also I'm stating this is because we have a meeting every semester with the industry and with people that have hired our students. And one of the things that they raised in one of our meetings is that students were not professional when sending emails. So that's what I'm trying to address here. So make sure that when you communicate with companies, you communicate in the professional environment, that you also follow these guidelines. So when you're sending attachment, includes in the email the file name, what format it is in, and the version of the program. So I don't expect to see attachments in the emails unless you're submitting something late that I ask you to do and send me that via email. Attachments are going to be managed mostly through Canvas. So you're going to be uploading your homework on Canvas and other things as well. So if you end up sending something via email, it's because I have allowed you to do that, and I will encourage you to use PDF instead of any other format. Good topics for emails. Email your teacher if you have an easy question that can be answered in a paragraph or less. If you have an assignment, you are allowed to submit via email. If there's anything that you think can create some type of misunderstanding, like if you send me an email, I might not understand what you're trying to say, or yeah, it's better just to schedule a meeting and we can discuss that face-to-face via Zoom. So don't bring any topic that will require continuous conversation. Like if you feel like I was not just grading your exam, it's better for us to discuss that via face-to-face because I want to avoid any type of misunderstanding. And again, if you have those type of concerns, the worst thing that can happen to you if you have a question about the exam and how it was graded is that you keep your same score. Most likely, if you have a valid point, you will end up getting extra points. So don't be afraid to discuss those type of things with me. I'm open to those discussions and to hear your arguments for that. Last thing, this is some information about me. I'm your instructor for this semester. I'm from Puerto Rico. I have an industrial engineering background. I have a bachelor degree, graduated in 2004 from the University of Puerto Rico. And then I did my PhD also in industrial engineering from Texas A&M University, worked as a postdoctoral research associate until 2012. And then I came to Texas State University. Within those time periods, I worked for a year in the bank industry. So I have experience with finance. That happened between my bachelor degree and my PhD. And I also have multiple internships. I have internships with General Motors and transportation companies and so on. So I have had the opportunity to work in different environments as an industrial engineer. So like finance, transportation, companies such as GM and Johnson and Johnson. So I have a good perspective of what we do in these different environments. In terms of research, like if you're interested in research, these are some of the areas that I work with: healthcare systems analysis, reliability in terms of wind energy and clean energy, and discrete event modeling and simulation, optimization, operational research, stochastic programming as well. Okay, so we got to the end. I think we are running out of time. So this is what we cover today. As I mentioned, I encourage you to reach out to me during my office hours or via email. If you need to talk to me individually, schedule an appointment and we can talk via Zoom. I will send you an email with the link and the time to meet. So let's try to make the best of this semester. And if you have any questions, then you can ask them now. Yes, I have one question. Great. So if there's no questions, then we are done for today, and we'll continue our communication via Canvas, and next video will be available by Wednesday morning. Okay, have a good rest of the day, and I'll talk to you later.
Thank you, Professor. Have a good day.
You too.